Before we go over the properties of exponents, let's start by introducing what an exponent is. Exponents indicate repeated multiplication of the same quantity. This means that we're multiplying the same number multiple times. An exponent is this small number written above and to the right of the base number. That tells you how many times to multiply the base by itself. For example, we have a to the m power here. A is the base, and m is the exponent. And a to the m means that we're multiplying a m times. So there's m factors. As another example, we have -3 to the 4th power. -3 is the base, and 4 is the exponent. This means that we're multiplying -3 4 times, as shown right here. An important thing to know about exponents is that when a is a non-zero number, a to the 0 is equal to 1. Now let's practice by evaluating some exponents expressions. So first, we have 2 to the 5th power, so our base is 2, and our exponent is 5. This means that we're multiplying 2 5 times. Do that. 2 multiplied by 2, multiplied by 2, 5 times. So 2 multiplied by 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we know 2 to the 5th power is 32. Now, what about this one? We have -x to the 4th power. This means that we're multiplying -x 4 times. As you can see, the negative here is inside these parentheses, which means we have to have it in our parentheses as well. So these two negatives will make it positive, and these two negatives will make it positive. Our answer is going to be positive, and we have 4 x's multiplied together, so it's going to be x to the 4th power. And what about this one? We have -4 to the 3rd power. This means we're multiplying -4 3 times. -4 times -4 times -4. As you can see, these two negative signs will cancel out and make it positive, but we still have a negative here, so we know it's going to be negative. And we have 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So our answer is going to be -64. Now we're going to start covering rules for exponents. Our first rule is product rule. This means that assuming a is a real number, and m and n are integers, a to the m power times a to the n power is equal to a times m plus n. So when we're multiplying, we're going to add our exponents. We can only do this if the base is the same. So in this case, we have 5 times 5 to the 2nd power times 5 to the 3rd power. In this case, we add it up, so it's going to be 5. This is implied to be a 1 here, so 1 plus 2 plus 3. So this gives us 5 to the 6th power. For our second one, we have 4 squared times 2 to the 3rd power. In this case, you might be tempted to add up the exponents as well, but as you remember, a needs to be the same, right? It needs to have the same base. So we're going to actually write 4 to the 2nd power is something in 2. So 4 to the 2nd power is actually 2 squared. And we can continue on. So 2 squared, 2 to the 2nd power squared is actually going to be 2 to the 4th power, which you can multiply these two. So it's going to actually end up being 2 to the 4th power times 2 to the 3rd power. So it's actually going to be 2 to the 4 plus 1 plus 3, which gives us 2 to the 8th power. When you're using the product rule and most rules for exponents, you have to make sure that you have the same base. Now we have the opposite of the product rule, which is the quotient rule. Same thing as before, a needs to be a real number, m and n have to be integers. In this case, a to the m power divided by a to the n power is equal to a to the m minus n power. So this time, when we're dividing, we subtract the exponents. So here, we have 7 to the 13th power, and on the below, we have 7 to the 5th power. and we know we can subtract. We'll do 7 to 13 minus 5 is going to be 7 to the 8th power. What about below? We have a lot of different variables here, but we can do the same thing. We have to remember that we can only cancel stuff out if it's the same base. So let's start. We have A, we have 6 on the top and 2 on the bottom. To know A, we can do 6 minus 2. And now we can look at our B's. For B's, we have 3 on top and 1 on bottom. So B is going to be 3 minus 1. And for C, we have 1 on the top and 3 on the bottom. C is going to be 1 minus 3. We have to remember we're always subtracting the top from the bottom. So here, we get A to the 4th power, B to the 2nd power, and C to the negative 2nd power. You can also write this as A to the 4, B squared over C squared. If you have something that's a negative exponent, you can move it to the bottom to write it as a positive number. You can either write this as C to the negative 2, or you can divide the entire entity by C squared. Both are right, and both mean the same thing. Now we have the power of a power rule. If A is a real number and M and N are integers, then A to the M, all to the nth power is equal to A times N plus N. So in this case, M is an exponent and N is also an exponent. So we're bringing this entire entity A to the M, all to the n power. In this case, we have x to the 1/2 the 2nd power, which means in this case we do x times 1/2 times 2 is equal to x. For the bottom, we have 3 squared, all to the 2nd power. In this case, it's going to be 3 to the 4th power. Here, we have the power of a product rule. A and B are real numbers, and M is an integer. So in this case, we have A times B multiplied together, all to the n power. We're saying that's the same as doing A to the n power times B to the n power. So in a way, it's just kind of like, are you taking it to the exponent first, or are you multiplying together and then taking it to the exponent? And it's going to be the same thing. So in this case, B times C to the 3rd power is equal to B to the 3rd power times C to the 3rd power. What about this one? This one is also similar. So this one, okay, we're going to start off with the 2. So 2 to the 2nd power is going to be 4. And then we have x2 to the 2nd power, so it's going to be x to the 4th power, right? Because 2 multiplied by 2. And now we have y3 to the 2nd power, so it's going to be y to the 6th. Basically, the idea is that you can separate these out. So multiply this one first, then this one, then this one. The power of a quotient rule is similar to the power of a product rule that we just talked about before. The idea is that A and B are real numbers and M is an integer. So A divided by B to the n power is equal to A to the n power divided by B to the n power. So with this one, it's similar to the other one. It's the idea that we can take the exponent first and then do the division instead of dividing first and then taking the exponent. So in this case, it's like order doesn't really matter. So in this case, it's saying that this is equal to 1 to the 3rd power divided by 3 to the 3rd power, which is equal to 1 divided by 27. For this one, you can also divide it out and do x to the 2nd power divided by 2 to the 2nd power, which is equal to x squared divided by 4. Now, let's do some practice problems using the exponent rules that we just learned. First, we have a to the 7th multiplied by a to the 13th. What rule do we need for this? We need product rule. So in this case, we know it's going to be a equal to 7 plus 13, which is equal to a to the 20th power. What about this one? We have 2b cubed all to the 4th power. In this case, we need power of a power rule and also power of a product rule. So first, we can use 2 to the 4th power, and then do b cubed to the 4th power, which is going to be b times 3 times 4. So we know it's going to be 16b to the 12th power. Sometimes you just have to combine rules to simplify your expression. In this case, we have 9c to the 3rd power divided by 3 times c to the 6th power. In this case, we need quotient rule. First, we can start by simplifying only numbers. 9 divided by 3 is 3. In this case, we use quotient rule to see that c is going to be 3 minus 6. So you know it's going to be 3 to the negative 3 power. Can also be written 3 divided by c to the 3rd power. Whenever you have a negative exponent, you can make it positive by bringing it down into the denominator. Now we have this one, c times d to the 5th power. This one's going to be power of a product rule. So we know this is going to be c to the 5th power multiplied by d to the 5th power. And what about this one? We have 2x divided by y all to the 3rd power. This one is going to be power of a quotient rule. So this one, we're going to do 2x to the 3rd power divided by y to the 3rd power. This gives us 8x cubed divided by y to the 3rd power. What about this one here? This one is also going to be quotient rule. So first, we start by simplifying. We have 20 divided by 60, that's 1/3. And now we do quotient rule. It's going to be a to the 2 minus 1 because we have 2 up top and 1 on the bottom. For b, it's going to be 1 minus 1. And then for c, it's going to be 3 minus 1. This gives us 1/3, a to the 1st power, b to the 0th power, and c to the 2nd power. Like we covered before, any number to the 0th power is equal to 1. So this is basically equal to 1/3 times a to the c squared. Now we finally reached our final challenge question. Pause and see if you can get the correct answer before I solve it. Now, let's get started. We have 2x cubed times y times 5x to the 4th, y squared, all to the 3rd power. Now, there's multiple ways that we can approach this, but let's start by just simplifying what we have inside first, and then I'll bring it to the 3rd power. We can do this. 2 times 5 will make that 10. And now, let's look at our x's. We have 3 here, and we have 4 here, so let's add it up. We have 3 plus 4. And for y, so we have 1 here and 2 on this side, so let's add up as well. 1 plus 2. All to the 3rd power. Let's start by simplifying. We have 10 times x to the 7th, y to the 3rd power, all to the 3rd power. Now, we can simplify using power of a product rule. So let's do this. We get 10 to the 3rd power times x to the 21st power, because 7 times 3, times y to the 9th power. So now we can fully simplify and I get 1000 x to the 21st power, y to the 9th power. And that's the end of this video. Thank you so much for watching.